For the first simulation model, a static stress simulation is carried out for the base of the self-balancing delivery container. There are two forces acting on the model. A 50 kilo force, as you can see here, are acting on the surface of the base, while a 50 kilo bearing force are acting on the cylindrical region below the base. A constraint has been set to the pin joint, since our base can move left or right by controlling the motor. The diagram here shows the simulation result for the safety factor. Safety factor 15 shows that the component meets the HHE and it is safe to use. Next, let's look at the stress applied on the component. The maximum stress is 0.71 megapascal, while the minimum stress is 1 times 10 power of -4 megapascal. If we compare with the mechanical property table, aluminum alloy has the yield strength of 25 megapascal minimum, since our maximum stress is 0.71 megapascal, which is much more smaller than the yield strength of the material. So the component can still withstand a lot of stress until it reaches the yield point. Move on to the displacement analysis. The maximum displacement of the component is 0.001741 mm. So the value is very small and it won't affect the shape of the component. Hence we can say that the component is strong and not easily to deform.
Next, we look at the second simulation model, which is the thermal heat simulation on the food delivery container. The maximum temperature applied is set to be 80 degrees Celsius. Next, moving on to the heat flux, also known as the thermal flux. It is the rate of the heat energy that passes through a surface. From the diagram, we can clearly see how the heat flow. The amount of heat acting on the cover of the container is higher than other places, as there is 2 heating rod places on the top of the container. The blue region here showing that the rate of the heat flow is low from the outer region of the container, as we don't feel hot when we touch the container. In short, this container is able to insulate huge amount of heat from inside, hence it is safe to use.
We will now look into the circuit and programming of various systems within our product. Firstly, we will start with the thermocouple and Arduino Uno interface. The thermocouple is actually a thermoelectric sensor which gathers and feeds input into the Arduino, while the Arduino is a microcontroller which controls algorithms. On this slide, you can find the schematic diagrams as well as the code written to program the system. Next, we will look into the heater control system. And as you can see, the schematic diagram as well as a snippet of the code can be found on the slide for your reference. This system actually regulates the temperature in the hot compartment according to the set point. And this is done by feeding input into the heater supply. And next we will look into the fan control system, which is the cooling system of our product. It actually operates similarly as the previous system, which is the heater control system, but it utilizes an axial fan instead of a heater supply. The schematic diagram and the code can also be found on this slide. Consequently, we will now look into the combination of the two previous systems, which is the heater and the fan control system. This system allows us to facilitate the simultaneous operation of both systems within the product. And as you can see, I've included the schematic diagram as well as the code written to program this system. Last but not least, we will now look into the self-balancing system of our product. As you can see, I've included similar schematic diagrams as well as the snippet of the code used to write the system. This system consists of an inertia measurement unit, which is an electronic device which measures tilt angle and tilt angular speed using a combination of accelerometers and gyroscopes. And that will be it for the circuit and programming segment of the presentation. Thank you very much.